students, we will continue with solids, that is with volume of three-dimensional objects. Today first we will see when water is coming out from a pipe or a tap. In that case, what is the volume of water that comes out? How do we calculate that? The volume of water flowing out from a pipe would be equal to the area of cross section of the pipe. The pipe will be like this. So you will have a circular area of cross section. So that area of cross section is generally pi r squared because it's the area of a circle where r is the radius of the pipe into the rate of flow of water. Obviously, if the rate is very high, then the amount of water, that's the volume of water that comes out, will be much more. And if the rate of flow is very slow, the tap is very slow, then in that case the volume of water that comes out would be less. The main thing you have to make sure in this sort of a sum is that everything should be in the same units, in the same system. So if this volume of water coming out from a pipe is in centimeter cube, then you will have to have area in centimeter squared and rate of flow of water in centimeter per second. So that is something you have to keep in mind. So here one more thing you have to remember, which you have already written, is 1 liter is 1000 centimeter cube 10 raised to 3, which is 10 raised to minus 3 meter cube. So that is another conversion that you have to remember, because sometimes you find the answer in centimeter cube and then you are supposed to convert it into liter. And this area of cross section is usually pi r squared, that is if it is circular. Usually the pipes are circular, maybe in a sum or two it may be given square, but usually the pipes are circular. So with that we will see the question number 12 on page 158, the classwork sum. It is given that the area of cross section of a pipe is 5.4 centimeter squared and the rate of water is pumped out at 27 kilometer per hour. So now the first thing is, this is in centimeter squared and this is in kilometer per hour. We can't directly multiply. We have to first convert kilometer to centimeter. First kilometer to meter is multiplication by 1000. Then meter to centimeter is multiplication by 100. So you will have 1 kilometer is 10 raised to 5 centimeter. So that is why it is multiplied by 1000 to convert it into meter first, and then meter to centimeter multiplied by 100. Same way, this is per hour. We will convert it into per second. So you have 1 hour is 60 minutes into 60 seconds. So 1 hour is 60 minutes into 60 seconds. So the hour is converted to seconds. So this, when you simplify, it comes to 750 centimeter per second. So the rate of flow of water is 750 centimeter per second and the area is 5.4 centimeter squared. Now the units are the same. So you will get volume of water flowing per second in 1 second in centimeter cube. That is what you get when you multiply 5.4 into 750. But the question asks you to find the volume of water flowing in 1 minute. So if in 1 second this much water is coming out, in 1 minute it will be 60 times that, because in a minute there are 60 seconds. So 60 into 4030 centimeter cube would be the volume of water that flows out of the tap in 1 full minute or 60 seconds. So now this is in centimeter cube. You are asked to find the volume in liters. How many liters? So you have this relation that 1000 centimeter cube. So 1000 centimeter cube would be 1 liter. So this 1030 and centimeter cube can be directly replaced by removing these 3 and centimeter cube with liter. So the answer will become 243 liter. That is the water flowing out of the pipe per minute. So this is how you do a sum in which the rate of flow of water is asked. Mark this as important. Yeah, in the next sum, you are given that there is a square shaped tube. So the square shaped tube has some thickness. The thickness we are assuming it to be x. The inner part, the inner area, the side is 5 centimeter. It's in the shape of a square. So obviously this side and this side, both sides the thickness is x. So you will get the side of the outer square is 5 plus 2x. Same way all the 4 sides are 5 plus 2x, because here also you will have x and x both sides. So outer area, because it's a square, will be 5 plus 2x the whole squared, and inner area will be 5 squared. Now the length of this tube is 8 centimeter. So that's the length of the tube. You are given that the volume of iron that is there in the cube, in this tube, is 192 centimeter cube. So that means what you are doing is outer volume minus inner volume, because this is hollow. Only this part is, the shaded part is iron, and that is to a depth of 8 centimeter. So this is hollow, so you have to remove the hollow part, which is air. So 192 is equal to the outer volume minus inner volume. So we can take outer area minus inner area into length, because length is common for outer and inner. So thickness we took as x. So outer area, area of the outer square is 5 plus 2x the whole square. Area of the inner square is 5 squared. That into 8 centimeter, which is the depth. That is 192 centimeter cube. So when you expand, 5 squared is 25, 2x the whole squared is 4x squared. This is 10 2s are 20 and minus 25. So you are left with 4x squared plus 20x. That 8 I have brought below the 192 and divided it is 24 times. So the 24 is shifted there and 0 is written this side, because you are getting a quadratic equation, 4x squared plus 20x minus 24. Now it is splitting the middle term, but before that, since you are finding values, this is not factorization. In factorization, we don't do divide by 4. We will split this itself and find the factors after taking 4 common out. We will not eliminate the 4. But here we are taking 4 common out by dividing both sides by 4, because you want to find what is the thickness, that is the value of x. So you get 4x squared ke badle you get x squared plus 5x minus 6 is 0. So now that middle term can be split as 6x minus 1x. Why? When you add, you should get 5x with plus sign, and when you multiply, it should give you minus 6x squared. So that is possible when you split it as 6x and minus 1x. Minus 3 minus 2 not correct, plus 3 plus 2 not correct. So that is not possible. It is only 6 and 1. So then when you split it and factorize it, you get x is equal to 1 or x is minus 1. Now side or thickness cannot be negative. Therefore the thickness is 1 centimeter. This thickness is of 1 centimeter. So that is what was asked in this particular sum. It is a volume sum. This sum is important. Mark this sum also, like the previous sum 12. This is also an important sum. See, now consider the next sum. You are considering a tunnel. The tunnel is having the floor, of course. It is given that it is a floor which is having a length of 7 meter from end to end. That is from A to B, the distance is 7 meter. Now just consider this tunnel. It is basically 3 surfaces. This is one surface which is this internal area. Then you have this as the top, which is another surface, and this side is identical to the right hand side surface, and left hand side surfaces are identical. So this is like the tunnel is. Two sides, this is the left hand side and the right hand side wall, the top of the tunnel and the floor. This floor depth distance is given as 7 meters. It's not rectangular. These two sides are slanting. So the floor width is given as 7 meter. The top given as 5 meter. This floor is 7 meter and the height, the perpendicular height is 2.4 meter. Now you can remember it as those three books, then this sum becomes very simple. This is the book which I had kept on the top. This is the book which I had kept on the left hand side, and this is the book which I had kept on the right hand side. So basically the length of the tunnel, that means the book on top, this length was 40 meter. So that's the length of the tunnel. It is quite a long tunnel. It is going to cover some distance of 40 meter. Now you are given that DC, that is the top surface, was 5 meter in width, whereas the base, because the tunnel was tapering, it is in the form of a trapezium, therefore the base is longer, it is 7 meter. You are also given AM is equal to NB, so we consider both of them to be X. Now DC and MN are both parallel and the angles are 90 degrees, so it's a rectangle. So you can say that quadrilateral DCNM is a rectangle, and therefore you have DC is equal to MN, and both of them will be 5 meter. Now if 5 meter is gone and this is 7 meter, that means the X plus X would be 2 meter. So X will be 1 meter. So that's the first thing, we have found X. Then we know that the height is 2.4 meter. So from that we can use Pythagoras theorem and find what is AD. AD is what I had placed at the side this way, slant. So I am finding this surface, what is the length of this surface, which is kept this slant. So from the square root table, I will find what is root of 6.76. Now that is 2.6. How did I get? Of course, 2.6 into 2.6 is 6.76. Besides, you can refer the page number 219 of your Anish tutorial textbook and you can see the square root table. Now how to look at 6.76? You are given on that page square roots between 1 and 10. So you will look at 6.7. 6.7 is given, but you won't look under 0, 1, 2, 3. You will look under 6.7 under 6 because you need 6.76. So 6.7 across and under 6 is 2.6. So that means root of 6.76 is 2.6. Please look at that page 219 because you would be provided a similar table in the exams when you have the final exams. So when you take the square root, you can find the actual value, that will be 2.6. That means in the tunnel we had these two sides. At the sides, this side is 2.6 and this side is also 2.6. They are identical. The height was 2.4, but we are interested when we paint. We are going to paint this rectangular surface fully. So this is 2.6, the length. It was kept slant, but this length is 2.6 and this depth is 40 meter. The depth of the tunnel is 40 meter. So this area is 2.6 into 40. Like that, both the surfaces you have 2.6 into 40 plus that is also 2.6 into 40. So there are two side walls and the roof which was placed on top is 5 meter and the depth is 40. So the roof also you are going to paint this full surface. So this surface, this is 5 meter and the length is 40. So 5 into 40 and 2.6 into 40, but two surfaces, left hand side and right hand side. So you have 2.6 into 40 into 2. This is the left hand side and right hand side, two side walls. And area of the roof is 5 into depth of 40. And the cost of painting is 5 rupees per meter squared. So the entire, both of them add together 408 into 5, so rupees 2040. And the next thing is the floor. Now when you enter a tunnel, if you are driving your car, you will see if it is 7 meters, throughout 40 meters, the floor is 7 meters width itself. So flooring is 7 meter, and then that's the width of the tunnel, 7 meter, and the depth is 40 meter. So AB, that is 7 meter into 40, has to be paved, means concretized. So that into 18 rupees is the cost of concreting per meter squared. So that gives you 5040. So once you understand that this is one book which I placed, this is another book which I placed. So AD, when you consider the depth, it is this surface of the book. This surface, so this is 2.6 and this is 2.6 and this is 40. 2.6 and 40. So you know this is what you have to paint, the internal surface. And that side also again the same way, it is 2.6 and depth is 40. So these two internal surfaces are the two side walls you have to paint. And on top, it is again 40 meter in depth, but now the width is 5 meter. So 5 into 40. So that is the entire three surfaces, 1, 2, 3 internal surfaces which you have to paint. So that into cost of painting. And the floor is the entire width into the depth, that has to be paved. So the entire width is 7 and the depth remains 40. And the cost for paving the floor is more than that of painting, of course. So it is 18 rupees. So that is why the total cost is 5040 for paving the floor, and this is for painting the three surfaces. Well, in the 15th question, it's a very simple question. Best thing to do is split the given figure into two cuboids. This is one and that's the other. I have split it. The figure is actually these two things joined together where the total length was 9. Now this is one cuboid and this is another cuboid. This is 3, height is 9 and width or depth is 4. So volume of this you can find 3 into 4 into 9. And the second one, the width is 6, the depth is 4 and the height is 3. So 6 into 4 into 3. So 108 plus 72, that is 180. All measurements are given in centimeter. So volume of the entire solid is 180 centimeter cube. So this sort of sum is an extremely simple sum and can be asked because in the boards they generally ask very basic sums. You just have to look at the figure and split it and write the 3 volumes. And you show this figure also. So then once you show this figure, you don't have to explain. Otherwise you will have to sit and explain. We can consider it as two separate cuboids. The first cuboid has a height of 9, width of length of 3 and the depth of 4. All that you will have to write. So much simpler than writing all those 6 steps, 3 steps for this and 3 steps for this, is to just show the figure and you can mark this as your length, this is your length, this is the height and this is the breadth. So you can show that as L1, B1, H1. And for the second one, this is L2, B2 and H2. So just mark it there in the figure and do the calculation. It's very simple. So now the next sum, to understand it, actually you take a rectangular piece of paper. One paper has been taken, that is question number 16. And then from the four corners you have cut four squares. So all the sides of the squares are same, they are 3 centimeter each. So from this left, everywhere, all four corners, I have cut the squares. And then I am going to fold this like this. So now I have got a box. So this is a box. So in this box, from the outer length, I have removed x and x, and from the outer breadth also I have removed x and x. So now that x and x is 3 centimeter. So from 32 I have removed 3 here, 3 here. So the base area of this box, base length, is 32 minus 3 and 3, that is 32 minus 6. So it is 26. This is the base of the box. Because you are folding the sides. 3 centimeter has gone from here and 3 centimeter when we went from here. So from the bigger rectangle, 3 has gone from this side and 3 has gone from this side. So 6 centimeter has gone. So out of 32, 6 gone. So this base length is 26. Same way from this, which is actually 26. This breadth is 26. 3 has gone here and 3 has gone here. So the base of the box is 26 minus 6, that is 20. So you have this box made where this length of the base is 26 and breadth of the base is 20. So 26 and 20 are the length and breadth of the base of the box. And how much is the height of the box? It is this 3 centimeter. Since you had cut 3 centimeter in all the four corners, that 4 parts are the parts which are removed. So this part is gone, this part and this part is gone, and it is folded. So when you fold it, what is the height? The height will be the part which is removed. So that is 3 centimeter. So the volume of the box, volume means capacity. How much matter can be filled in it? How much water maybe can be filled in it? The volume of the box will be equal to the base area into height. Any volume is base area into height. What is the volume of your house ka room? The base area into height. So here the base area is the length and breadth, which is now 26 and 20, and height is that 3, which is giving you a total answer of 1560 centimeter cube. So that's on, you have to think a bit, but once you have seen this and you know how you make the box, then it is very simple. So from 32 you removed 3 and 3, so you got the base of the box as 26, and from this breadth of 26, you removed 3 and 3, so this breadth of the box base is 20, and the height is 3 centimeter, that is the square that is removed. So that height is 3 centimeter. So 26 into 20 into 3. That's the total volume of the box. So the 17th question, it is given water flows into a tank 150 meter long and 100 meter broad. Make that correction. It is not 100 mm, it is 100 meter broad. So it's a big tank, 150 meter by 100 meter. So the base area of the tank will be length into breadth. So that is 150 into 100 or 15 into 10 raised to 3 meters squared. And the depth or height to which water is filled is 7 meter. So that the volume of water in the tank when the water level is 7 meter is this base area into height. So 150, 15,000 into 7. So that's the volume of water in the tank. That is equation number 1. Now this is filled by using what? It's filled by a rectangular pipe. The pipe is rectangular in shape. So the area of the front is like this, in the shape of a rectangle. Length is 5 decimeter and breadth is 3.5 decimeter. Now decimeter in physics measurements chapter first we had learned standard prefixes. Deci is 10 raised to minus 1 meter. Centi is 10 raised to minus 2. Milli is 10 raised to minus 3. So small d stands for deci, that is 1/10 of a meter or 10 raised to minus 1. So this means this is 0.5 meter into 0.35 meter. That's the area of cross section of the pipe. Now volume of water flowing out from the pipe in 1 hour is area into this area into rate at which water flows out of the pipe, because this rate is given as 15 kilometer per hour. So it will be 15,000 meter per hour. I have left it as hour only, I have not converted it into seconds. My final answer, how many hours it takes to fill the tank, I will find in hours. So volume is this area 0.175 meters squared into rate of flow of water, that is 15 kilometer per hour, which is converted to 15,000 meter per hour. So this is the volume per hour. This is not the volume, total volume, but per hour, so much water is getting filled in the tank. So let's assume the number of hours required to fill the tank is h. So this volume into h, the volume per hour into number of hours, should give us this. That's the total volume of the tank. So this from equation 1 and 2. This is from equation 2 and this is from equation 1. So from that you will get 175 into 15 into h is equal to total volume, that is 15 into 10 raised to 3 into 7. That is the total volume of the tank. Then you calculate, it's a simple calculation, you will get h is 40 R. So please make this correction in this sum. It is not millimeter, it has to be meter. The breadth is not 100 millimeter, it is 100 meter. So the answer, final answer is 40 R. You can leave it in R. Yeah, mark the 18th sum is important. In this sum, they have given you that a rectangular tank is 25 meter long and 7.5 meter deep. If 40 meter cube of water is removed from the tank, the level of the water tank goes down by 1.8 meter. So this is the part of water which has been removed. Initially it was filled with water. So when the depth goes down by 1.8 meter, that means 540 meter cube of water is removed. So what is the volume of water removed? It is the base area. The base area is the same into height of water removed. So base area is 25 into breadth. We don't know breadth. We are asked to find the breadth. And the height of water removed is 1.8 meter. That gives you 540. From that, you can directly find B, that is the breadth, which is 12 meter. After that, you have been asked to find the entire capacity of the tank, which is length into breadth into the total height. So 25 into, you just got this as 12 into 7.5, which gives you 2250 meter cube. So here remember, when you have removed water, the height or depth of water removed will be considered with the base area, which is constant. So that will give you the breadth as 12, and the total volume is length, breadth and total height. Going to the last sum of this chapter. With this we will be finishing solids. How many cubic centimeter of iron? That means they are asking you what is the volume of iron are there in an open box whose external dimensions are, externally it is 36 centimeter by 25 centimeter and height is 16.5 centimeter. Whenever you are given three dimensions, it is always length into breadth into height, not any other order. Length is 36, breadth is 25 and height is 16.5. The iron being 1.5 centimeter thick throughout. So this side, that side, all the four sides it is, and it's a box. Box means base would be there, top is not there. That's why it's called open box. So the top is open. So on the top surface there is no iron. So that is the important part here. Open box. So top is not there. So maybe it's like a container. So because it's an open box, the top is not there. So it's very simple to find the external dimensions and the external volume. It will be length into breadth into height. Length is 36, breadth is 25, and height is 16.5. So that multiplication gives you 14,850 centimeter cube. Now internal dimensions of the box, from the length, both the sides 1.5 is gone. So that is why the remaining internal length is 33. 36 minus 3, 33. From the breadth also, this thick 1.5 from the front and back, both sides is gone. So 25 minus 3, 22. And the height now, from the height, there is no top. So you won't remove from top anything. Only from the base, that 1.5 will go. So you are not doing 16.5 minus 2 times 1.5. It is only 16.5 minus 1.5, that is 15. The reason is the top is open, there is no top. So only from base 1.5 centimeter is removed. So this is the important thing. Many people go wrong here. They do 13.5, they take it as 16.5 minus 3. It is 16.5 minus only 1.5. So that is because the base is there but the top is open. So this is having dimensions 33 into 22 into 15. That is 10890 centimeter cube. That is the volume of the inner or the hollow part. So how much metal or how much iron is there? That volume would be external volume minus internal volume. That is 14,850 minus 10890, 3960. That's the volume of iron. Now they have also asked you to find the weight of the box, the weight of the empty box. It is given that 1 centimeter cube of iron weighs 15 gram. So therefore, this much is the actual iron which is there in the box. 3960 centimeter cube will weigh X. So when you do cross multiplication unitary method, you get X is 3960 into 15, which is 59,400 grams. Converted into kg, it is 59.4. You divide it by 1000. So it would be 59.4 kg. That box is a heavy box which weighs 59.4 kg. With that we have completed solids fully. So bye, have a nice week.